Right. So in this video, we're going to talk about how to factorize cubics, and this time we do have a constant here. And later on of the video, we're going to talk about different factorize, which is using the cubics formula and rational root theorem as well. So um, let's get started. So here I have an example here. They said show that x plus 1 is a factor of this cubic and 5 other linear factor. So the first step that you're going to do, if you want to show something is a factor, so technically it's saying x plus 1 equals 0, it will be x equal negative 1. So you're going to show that when you substitute negative 1 in, the answer will be 0 based on remainder theorem. Okay, so we sub x equal negative 1 in here. We have negative 1 cubed minus 4 negative 1 squared plus negative 1 plus 6. Negative 1 cubed is negative 1. Negative 1 squared is 1 minus 4 minus 1 plus 6. And when you add these together, you end up having 0. So therefore, whatever the answer here is a remainder. So 0 is the remainder of that. Therefore, you would say x plus 1 is a factor, right? Now, the second part of the question is 5 other factor. So you know this cubic can be written x plus 1 times something that I don't know. What is that? So how do I know what is the inside? One method that I can do is I can do the table method, long division, to figure out the quotient here. So here I have 1, negative 4, 1, and 6. I write here 1, negative 4, 1, and 6. Okay. I divided by x plus 1, so I write that at x equal negative 1. Now, the number 1, I bring it down. Then I do negative 1 times 1 plus negative 4. That gives me negative 5. Then I do the same thing, negative 1 times negative 5 plus 1, that gives me 6. And then negative 1 times 6 plus 6 give me 0, right? So 0 is a remainder. And you can see 1, negative 5, and 6 is the quotient. So I would have 1x squared minus 5x plus 6, like that. And finally, I can factorize x squared minus 5x plus 6. Two numbers add together equal negative 5 times together equals 6, which is 2 and 3. Negative 2 and negative 3, so I write x plus 1, x minus 2, x minus 3. Okay, here is another example. Here I want to factorize this, okay? Now, factorize, and I do have a constant 30. So my first step is a bit of trial and error. I'm going to find a factor first. And the factor is I'm going to look at 30 and I'm going to guess what's the factor of 30. So it could be plus minus 1, plus minus 2, plus minus 3, etc. Okay, all of it. 1, 2, 3, 10, 15, and 30. But usually the smaller number is enough. So you're going to do a bit of trial and error. So you substitute 1 in and see if it ends up having equal 0 as a remainder. So x equal 1, if you sub 1 in, 1 cube minus 4 times 1 square minus 11 times 1 plus 30. That won't give me 0, so I can't do 1. If I do negative 1, probably doesn't work either. So I'm going to try 2. So 2 cubed minus 4 times 2 square minus 11 times 2 plus 30. 2 cubed is 8 minus 2 square is 4. 4 times 4 is 16. 11 times 2 is 22 plus 30. This gives me 0. Lucky. So x equal 2. So you would turn out that x minus 2 is a factor. That's your first step. You find a factor. Okay. Now your second step is you just do long division. You just draw a table and then you find out what's the quotient. So here you have the coefficient 1, -4, -11, 30. Right here, 1, -4, -11, and 30. And you divide it by x minus 2, so you write x equal to here. Okay? Then what about the number here? Bring it down, so you have 1. Then you do 2 times 1 plus -4. 2 times 1 is 2 plus -4 is -2. Then you do the same thing. 2 times -2 is -4. -4 minus 11 is -15. 2 times -15 plus 30. That gives me 0. So I can write that x minus 2 right here. And you can see these are the quotient. So 1x squared minus 2x minus 15. Okay. And then you just factorize the inside, which is times you get -15 and you get -2, which you get -5 and +3. There you go. That's how you factorize into 3 linear solution. And now if they want to solve it equal 0, then you just let it equal 0. You get x equal 2, x equal 5, and x equal -3. All right. Here we do have um, another method. Sometimes if they just ask you to factorize cubic, but you only have 2 terms. So the faster way to do this question is just use the cubics formula. If you have a cube plus b cube, that would be a plus b a squared minus ab plus b squared. Okay. If you have a cube minus b cube, that would be a minus b a squared plus ab plus b squared. And the thing inside, they cannot factorize further. All right. So the whole idea, you just need to turn this into cube, something cube, and that's what we do. But before we do that, see the 8 x cubed and 64. First of all, you always take out the common factor first, which is 8. So you're left with x cubed plus 8. 8 times 8 is 64. Okay. Then you go to use a formula, cubic formula, and the plus, I use that. But before you do that, x cubed, 8, you're going to make into 2 cubed so that you can see a is x and b is 2. Then you apply the formula. So keep the a outside, don't touch it. So a, and then you have x cubed. So a cubed plus b cubed, a plus b, so x plus 2. And then in the bracket, you have a squared, which is x squared, minus ab, x times 2 is 2x, plus b squared is 2 squared, like that. And 2 squared, you can write that as 4. And there you go. That's you finish. Similar for B, but for B, this is a takeaway and there's no common factor. So you can turn each of them to cube straight away. 125 is 5 cube. So 5a and then write that cube minus b cube. Okay. Then we use the second formula here. A minus b, so 5a minus b. Then inside you have a squared. So 5a n squared like that plus ab 5a times b and then plus b squared like that. Okay, and 5a squared you can write that as 25a squared, get rid of the bracket, plus 5ab plus b squared, and we write these again, 5a plus b plus bracket. All right, now rational root theorem. Sometimes you want to factorize, again, this is similar to previous example, but you do have the coefficient here, right? So, if you record the remainder, finding the factor, so to find a factor of 3, factor of the constant, which is -5. The factor of -5 can be ±1 or ±5. However, if you do have a coefficient in front, the factor, potential factor, it can be plus minus every single factor here divided by every factor of Dre. So it can be ±1 over Dre or ±5 over Dre. So you could have a fraction as your factor. That's called rational root theorem. So rational root theorem is like if you have ax cubed plus bx squared plus cx plus d, let's call that b of x. If you um, if you want to find the potential, we're talking about the potential, okay? I mean, one of the number will work, some number will not work. So the potential factor will be, you're going to have all the factor of A, so all the factor of D. So all the factor of the constant divided by all the factors of A. That's called rational root theorem. Okay, so we have it right here. All right. Now we just need to do trial and error and see which one will give us 0. Now, if you actually try this, if you try 1 here, if you sub in, it won't give you 0. If you try -1, it doesn't give you 0. If you try 5, it also doesn't give you 0. But if you try a fractions, okay, if you try any fraction here, one of them will give you 0. All right. Now I'm going to try 1 over 3. And let's see if it's equal to 0. But the problem is when I substitute 1 over 3 in, it's really messy. I don't want to spend the time and do this whole fractions, right? It's too much because at the end, I just want to know if it equals 0 or not. So the best way when you deal with, if you need to find a factor that involving fraction, I think the best way for you to draw a table straight away. And if you didn't end up having a nice number, then it's not working at all. So you have 3a2 and -5, 3a2 and -5. Then you have x equal 1 over 3 here, okay? So 3 and bring it down. Then you do 1/3 times 3 is 1 plus 8 is 9. Perfect. Then 1/3 times 9 is 3. 3 plus 2 equal 5, right? Then you do the same thing, 1/3 times 3. So the moment that you have 1 over 3 times, so 1/3 times 5, it's going to give you a fraction, and a fraction minus 5, there's no way that this will end up 0. So you wouldn't want that, okay? So now I'm going to try 5 over 3. So if I try 5 over 3, sorry, so you have the 3, bring it down. 5 over 3 times 3 is 5 plus 8 is 13. Then I do the same thing. 5 over 3, if you times 13, going to give you a fraction. And a fraction plus 2, you're going to end up having fraction here, and we don't usually have that. So for sure, this one doesn't work because 5 over 3 times 13 is a fraction. Okay. Now I'm going to try -5 over 3 instead. So -5 on 3. So bring the 3 down. -5 on 3 times 3, 3 and 3 cancel out. So you have -5 plus 8 is 3. Then you do the same thing. -5 over 3 times 3, 3 and 3 cancel out. -5 plus 2 is -3. That one is perfect. And then keep going. -5 over 3 times -3, 3 and 3 cancel out. -5 times -1 is 5, 5 minus 5 is 0. There you go. So you would have, what you have is you would have x plus 5 on 3 as your factor, and you would have 3x squared plus 3x minus 3. All right. Then what you do next is, because you didn't want a fraction here, it looked messy. So what we do, we times everything here by 3. When we time everything here by 3, we divide everything here by 3. So we have times 3 here, 3x plus 5, like that. Then you divide everything here by 3. So x squared plus x minus 1. There you go. Do you see how you find a factor? Okay, and then to continue, you can continue factorize this. And you can do that either using a complete the square method or just use quadratic formula. So here I have 3x plus 5. Then I'm going to do complete the square here. So half the quicker way to complete the square is you're going to write x plus. So this is 1. So half of 1 is 1/2, like that, 1/2 square. Okay. And then to find what's the number outside, you do 1/2 square, you put the negative outside, and you have the -1 here. So -1/2 square is -1/4 minus 1. That gives you -5/4. That's how I complete the square in one step. Then you would do drops the difference of perfect square. So x plus 1/2 minus a square minus b square is a minus b, and b is the square root of that. So root 5 and square root 4 equal 2, like that. And then x plus 1/2 and plus root 5/2. Okay, and then 3x plus 5, you bring it down. All right, and so to summarize, how do we factorize cubics? I'm going to divide into 2 different steps. If you have a constant equal 0, so let's say ax cubed plus bx squared plus cx plus d equals 0. Okay, so we're talking about d equals 0. And if d not equal 0, so if you have something like x cubed minus 4x squared minus 12x or something. You don't have a constant here. So the best way to do factorize here is taking out the highest common factor. So take out HCF. What's the highest common factor here? We take x as a common factor. So you're left with x squared minus 4x minus 12, like that, which you end up having x and then x minus 12, sorry, x minus 2 number times together equal 12, as is 4 is minus 6 and plus 2, like that. Okay, so if constant equals 0, just take out the highest common factor. If constant not equal 0, like something like x cubed, what's the example we used earlier, like that, x cubed minus 4x squared minus 11x plus 30. So here we have the constant is 30. Then we would refer down to find a factor of 30. So find a factor of 30. Yeah. And then we're going to draw a table, and then we're going to find the quotient once we've done the table. Then we continue factorizing. So this is 2 main methods of factorizing cubic. There are special methods, and special methods only works in some cases. So special methods here. So if you have 4 terms, okay, 4 terms and they having the same ratio, let's say you have something like x cubed minus 6x squared plus 2x minus 12. So I'm talking about the ratio between A and B and the ratio between C and D, if they have the same ratio. So the best way to do this one is you group 2 by 2. So the methods we do here is we do grouping. So we group x squared, x minus 6. Then here we take the 2 out, 2x minus 6. Then you have x minus 6 as a common factor, and then you have x squared plus 2. Okay, so these methods work if it's four term and they have the same ratio. You can do this faster. Then you can still do this method. These methods work for anything that have the constant d not equal 0. But if it has the same ratio, it's better to do this. Okay, and lastly, if you have two terms that can make into something q plus something q, then you could just use cubics formula, aq plus bq, a plus b, a squared minus ab plus b squared, like that. And then aq minus bq is a minus b, and a squared plus ab plus b squared. So this one, when you have something like x cubed minus 8, you can match x cubed and make a into 2 cubed. Then you can just use the formula is x minus 2 x squared plus 2x plus 4. Okay, so generally speaking, cubics have four methods. Take out the hard common factor when we know the constant equals 0. If the constant not equal 0, then we find a factor and we do rational root theorem. If you look, and if it have four terms with the same ratio, we can do grouping. Or when they have two terms and they have cube in each term, then we can just use cubic formula.